So, it's the 9th of December, 2016, and this is episode 64 of the Unseen Podcast. This is your host, Paul Carr, and this is the last Unseen Podcast episode for 2016. We'll be back in mid-January with episode 65. Tonight is a Bring Your Own Forecast episode. Each of my panelists will present a forecast or a prediction for the near-term future with a fixed time frame and a measurable outcome, and the rest of us will evaluate that, and I think it should be a lot of fun. Tonight, joining me for the very first time is Ken Wisian. Hello, Ken.
Hello.
Ken Wisian. Who is Ken Wisian?
Okay, well, briefly, I'm a recently retired two-star general from the Air Force and Air National Guard here. Spent 33 years flying all kinds of aircraft, got to visit all the scenic spots in the world that have fighting going on. PhD in geophysics, although my recent work has mostly been in the space stuff, where I met Nick, for instance, at the Starship Congress. Talked a little bit about first contact protocols, Starship, things along those lines. So longstanding interest in all these areas, and looking forward to the conversation tonight.
Yeah, well, welcome, Ken, and we hope to have you back many times. Okay, and we also tonight have Nick Nielsen. Say hello,
Hi,
Nick.
Paul. Hi, Paul.
And from the UK, we have two people, Adam Smith.
Hello, Paul. Hello, unseen listeners.
And Chris Prophet.
Hi, Paul. Hi, everyone.
Okay, well, let's get right into it. I'm just going to go from left to right on my screen, which would be, start with Adam. Adam, what's your prediction?
My prediction is a space exploration prediction, and it involves NASA and the Russian space agency Roscosmos plans for the next 10 and 20 years. Currently, NASA don't have any specific plans for human missions beyond testing the new Orion capsule and the new space launch system, which ultimately it's hoped will take us to Mars. One mission that is on the table is an asteroid redirect mission. It involves sending a robotic craft to a near-Earth asteroid to survey it, characterize it, and take boulder-sized pieces of it to lunar orbit, where astronauts can go and sample it. I don't think that's going to happen. Not because it's a bad mission. It's going to be a very expensive mission, complicated mission, and I just cannot see it happening anytime in the next 10, 20 years. So I think NASA will quietly, I don't think they'll publicly say they're not going to do the mission, more likely to just keep it on their books and not talk about it very much in future. What we will see is an announcement, probably by President Trump and Putin, sometime in the next 2 or 3 years. I predict they will announce plans to build a cis-lunar base. What I mean by that is not a base on the moon, but in space, somewhere either between the Earth and the moon, or more likely in lunar orbit at one of the Earth-Moon Lagrange points. That is my prediction, yeah, that America, Russia, and probably the European and Japanese and Canadian space agencies will all come on board without the Chinese and plan a new cislunar base to test things like new spacesuits, new modules, new technology places us on the road to Mars.
Okay, now what time frame is that again?
I would expect an announcement within 3 years.
And when do you think they'll do it?
After the International Space Station wraps up its current operations in 2024, so will actually happen sometime in the late 2020s. Difficult. I always find it difficult when you try and say when something will happen. It's very difficult for me. I'm over optimistic. I'd like to say 2026, more likely 2030.
Okay, well, so we'll take 2030. Okay, so let's start with Chris. Chris, what's your thoughts on that?
Well, I think this is quite likely to come off, to be honest. I know NASA's been moving forward with their next step programs, looking to get modules that are suitable for cislunar space. Whether it involve the Russians, it's possible. I don't see any reason why not. I know it's the Trump sort of NASA landers and what have you. They've been talking about working with the Chinese, but I think when he gets to Congress with that idea, they might they might balk somewhat. So I mean, Russia is traditional partners. Cislunar is the seems to be the next step. I mean, to be honest, it makes a lot of political sense because prior to this, it's been about Mars. That's what NASA's aiming at. But when Mr. Trump comes in, he's probably want to have a break with preceding ideas and say, well, look, the moon's within our grasp, basically. We've been there, we know how to do it, and now we can set up a base there. So it sort of makes, and it's sort of on its way to Mars, so it's a logical step. So, yeah, I don't see any problem with that at all. I know Congress have been trying to accelerate the next step work and trying to get those modules produced a little bit quicker, but well, we'll see how that works out. So, yeah, I concur.
Okay. Ken, what about you? Hello, Ken. Can you hear me? Oh, your mic is muted, Ken.
Okay. I'm a little more pessimistic about any sustained major program for NASA. We have yet to see what the Trump administration's attitude towards NASA is going to be, but I wouldn't be surprised if he's more supportive of commercial enterprise in space, which is already gaining momentum now. So I'm not too sure about that. Same similar thought goes for cooperation with the Russians, although there's some advantages to it. Again, as was pointed out, I'm not sure Congress will buy into that very well. And when you're talking long term, it's hard to sustain cooperation with a frenemy for a long time. So a little more skeptical about that. My hope is more pinned on commercial enterprise continuing to step up. So I'm curious to see how that'll work out.
So would you attach a probability to Adam's prediction, or?
I'd put it more around 20%.
Okay. How about you, Nick?
The riskiest part of the prediction is the public announcement of a cooperation between Russia and the United States. And then secondarily, I think the focus on a cislunar base. What exactly does that mean? Does that, Adam mentioned a Lagrange point, or possibly in the orbit of the moon. I think it would be very difficult politically to finance something big that didn't actually involve, as it were, boots on the ground on the moon, because of the symbolic value of going back to the moon. So I think there would be a very strong push if people at NASA and or Roscosmos we're talking cislunar base. I think that the politicians who would give them dollars would say, yeah, but you got to plant a flag on the moon also. So I'm not saying it won't happen. And it's a great position, and it's great that Adam has extended himself with this risky prediction of a public announcement, because that's the kind of thing you want to predict, something with some risk in it. I would put that at about maybe 50-50. And I would put but if it does happen, I would say it's going to involve at least a minimal presence on the moon.
Okay. I guess right now I would say my heart is with what Ken says, but my mind is more with what Nick says. That we landed on the moon more than 50 years ago. Some of that knowledge base is lost, but SpaceX has demonstrated that you can build a throttleable engine these days. It's not that hard, so landing on the moon, even though some people will complain that, oh my gosh, nobody knows how to do that. Yeah, we do know how to do that. My question is, when you have when you're doing cislunar operations, how much of that is really different from LEO, and when they're looking at retiring at the space station, just a few, not that many years from now, is not an option for sustaining the space station going to be offered? My guess is it will be.
Couldn't we boost the existing space station to a Lagrange point or a cislunar orbit?
No, we couldn't do that. But
why not?
Not with any rocket that we have now. But for one thing, it's not this solid object. It's this very floppy thing. You'd have to cut it apart. You'd have to cut it apart and.
So you couldn't just attach a rocket motor onto it and slowly accelerate it to out of Earth's or immediate or lower.
Not a rocket motor that we have. You'd have to develop a completely new one.
Would ion engines do it?
Sorry?
Would ion engines work for that?
Potentially, but my gosh, I mean, it would take forever.
Patience, yes.
Yeah, I mean, you could. Yeah, I mean, ion engines would work in terms of less fuel, but fuel's not really the concern here. The concern is, why would you put something like the space station in that orbit? The answer is there's really no rationale for it. What I'm saying is what you can learn from being in cislunar orbit and what you can learn from being in low Earth orbit is not that much different. In terms of,
I disagree.
Okay, well,
lots of technologies that will need to be tested if people are going to go to Mars and if we're going to get out of low Earth orbit and go back to space proper.
As a way station for Mars, it makes a lot of sense. It gets you out further. It gets you, building boosters that can routinely get out of low Earth orbit. So that part
a booster that gets you to Earth Moon L1 is not anything like a booster that gets you to Mars. So I mean, it could be considered a stunt. Now landing on the moon and surviving on the moon and operating on the moon is difficult and is challenging, and that would be. While it's not really a rehearsal for Mars in any meaningful way, because Mars is different, it is something that I think could potentially garner political support. But for Adam's prediction that there will be this international cooperation to get into cislunar orbit to do, I mean, it doesn't have to be rational, right? I mean, it just has to be supported and paid for.
Paul, I do have a rationale why this is likely to happen. They've built a very big rocket called the Space Launch System, and it's basically a beefed up Saturn V. That's a moon rocket. So the SLS is entirely suited to go to the moon and put payload there. However, it's not entirely suited to go to Mars. If you look at the payloads, it'll put about 42 tons on Mars, right, which is not ideal if you've got to stay there for two years. But it can put a much larger payload in cislunar orbit, and they're really looking for some use for it.
Well, yeah, I
for it
mean,
to
if
exist
you
at the
if you're
moment.
looking for for a problem that technology solves, yes, but you know what we consider rational would be a technology that solves a problem, right? Right.
Well, I mean, there is one thing to going to cislunar is you're outside of the Earth's radiation protection, the magnetosphere. So you've got an entirely different radiation environment out there, and that's one problem they do have to solve going to Mars or existing on Mars.
Well,
So
that's true. Now, you know, again, speaking rationally, as if that were, as if that made any difference, we don't need humans to do that. We can measure radiation entirely without human help. You know, we don't have to see who gets cancer to find out how much radiation there is. There is an interesting question here, which is we don't know, and I'm going way past my time here, but we don't know how low dose radiation affects cancer rates. We know that if people get high dose radiation, they die from cancer at a certain percentage, right? But we don't know the kind of radiation you get in outside of the radiation belts. We don't know that.
But we can guess with a pretty high degree of confidence that it's going to be highly selective. It's like exposure to ordinary pesticides. Most people don't get cancer if exposed to ordinary pesticides, but if you expose 1 million people to pesticides, there's going to be a few that get a really nasty cancer.
Well, we don't know because we only have examples of people who've been exposed to very high doses of radiation, like Chernobyl or Hiroshima. People who've been exposed to low doses, that's all of us. And so we don't really know, we don't have that. You can't ethically do that kind of experiment. So we don't really know. I guess the first time we did that experiment is when we sent people to Mars. But so anyway, I'm going to wrap up here because I don't want to go on too long. I think Adam has a valid scenario. I would put a probability of about 0.3 on it, and let's move on. Oh wait, Chris, are you still there? Chris is not there. Okay. Let's move on to Ken then, your prediction, and we'll get back to Chris later.
All right. Well, mine is based on basically the Wild West that is the internet currently. And in general, I think the situation of intellectual property theft, attacks on the internet, theft of ID and money is going to get significantly worse before it gets better. My specific prediction is that within the next 5 years, we'll see a directly attributable loss of life to internet activity. Most likely, probably some criminal activity like holding a computer system for hostage or affecting a critical infrastructure of some sort. But I think you'll see something fairly soon where you have a direct line of an internet activity and a human death, other than in military terms.
Can you give us the mechanism there? I mean, how does somebody die from that?
Taking away a critical computer system, say in a hospital, full of instances recently where hospital computer systems have been held for ransom, locked down, can't get into them. So far, it hasn't affected a critical subsystem within a hospital, but it's probably just a matter of time.
Yeah, well, ransomware is certainly very common these days. We're seeing it everywhere. We're seeing some organizations paying the ransom, right? I mean,
Yes.
they'll pay the ransom rather than deal with the consequences of not having their computers.
And I'd say the chances are nearly 100%.
Okay. So what time frame are you talking about?
5 years.
5 years? Okay.
At the outside.
What do you think, Adam?
Could argue that many people have already died were problems with cyberbullying. I've no idea the actual number of figures, people that have committed suicide, but cyberbullying, ransomware. I've no idea whether anyone has actually committed suicide because they're unable to back on Facebook.
Not getting back on Facebook would be a blessing.
It's interesting because what the scenario that Ken described happened quite recently with my local hospital. About 2 months ago, I think, their non-emergency departments all shut down for 2 days, and they cancelled all routine operations. About two months ago, it didn't affect critical systems, emergency patients, but it did affect routine operations. But it's quite possible that this kind of thing could happen. Not so sure it's likely to take out emergency infrastructure. But I would hope that is well shielded. Probably in the UK it is, probably in America it is. Whether say the same thing about all countries across the world, probably not. I would imagine there are computer systems in developing countries that are much more fragile, perhaps, than in more developed countries. So could happen, but I have difficulty in attaching a probability to it. It's quite difficult to prove. It's one thing to say a person may have died because of this activity. It might be quite difficult to actually prove it in a direct causal link.
Yeah, I understand your question, but we have to be bold here and put a probability on it anyway.
I also do have a difficulty in plucking a number out of my brain, to be honest.
Well, yeah, that's exactly how probability works. It's a measure of belief.
I know that is exactly not what it is. And so I am loath to just pluck a number out of my brain without any data. I've run no statistical tests whatsoever.
So you're a frequentist on a Bayesian, okay.
I'll give it a probability of 0.41752.
Oh, wait a minute, no. The 2 is wrong. It's got to be at least a 5. Okay. Well, thank you, Adam. I think that's actually a pretty good response. Chris, your turn.
Oh, well, yeah, sounds entirely reasonable to me. I mean, the problem increasingly with crime is detection. There's getting more and more ways of being detected, more cameras, more surveillance, more known about you personally. I mean, so people, criminals, are moving into more anonymous areas, like as you say, taking people hostage online because increased anonymity. So yeah, I can't see any reason why this isn't going to happen. I mean, 5 years, yeah, I mean 99%, I'd say. It's got to be, because people are always going to sort of play brinkmanship and say, well, maybe we can hang on a little bit longer and work out how they're doing this.
I think we lost Chris for a second there. Nick, how about you?
I agree. I wouldn't put the likelihood quite as high. I think for the 5-year time frame, I would say that an actual death from electronic warfare, I'd probably put it 80 or 90%. But if we push it out to 20 years, I would say probably, 99 to 100%. These things will eventually turn kinetic, as they sometimes say. And there's many different ways that this could happen, whether intentionally or accidentally. If you took a hospital ransom with ransomware and you managed to gain control of their machines that are keeping people alive, you could end up killing people accidentally, even if the intent simply was to get to extort money from them. And since they have hospitals and universities have already proved, as you said earlier, that they're willing to pay to receive their information back, or access to the information or their systems again. It's like the de facto encouragements of piracy off the East African coast by paying literally millions of dollars to pirates who have taken large commercial ships. They have encouraged an entire industry of piracy, and the same things with ransomware. And who knows how long it's going to be. Certainly with 5 to 20 years, it'll go horribly wrong.
Okay, my turn. Well, I think Ken is probably right. It may not be a hospital, it may be a law enforcement agency that gets their wires crossed and ends up raiding the wrong house and shooting the wrong guy. That's happened before, just because of sheer incompetence. Here in the U.S., we have a highly militarized police force that will do drug raids like as if they were trying to track down bin Laden. The war on drugs looks like it's got at least 4 more years to go. So I'm afraid he's probably right, that the cyber warfare will result, or just cyber pranksterism could result in somebody getting killed who certainly doesn't deserve to. And so I'd put a 0.9 on it.
And the scenario that you describe also raises the very interesting question of how far out the effect can be and still can be considered a death from cyber warfare. So you just suggested somebody misidentified and killed by a police raid. You can push that scenario out further layers, and it becomes more questionable at each layer whether you want to credit that death to cyber warfare or just credit it to human error in the interpretation of information.
That's true.
Yep.
However, I would, I think that the less someone is expecting a police raid because they've done nothing wrong, the more likely they are to respond to it in a way that's going to get them killed. People who actually are drug dealers will probably know to put their hands up and fall on the floor as soon as the instant that SWAT team's at their door. Okay, Chris, you are back. Can we? Chris has been coming in and out. It's time for your prediction, Chris.
I just ask Ken a quick question.
Sure.
Go ahead.
Would you expect state-sponsored cyber warfare, denials of service attacks, that sort of thing, to accompany more conventional acts of warfare in the future? Are we going to see cyber warfare as an integral part of modern war?
Okay. Now, personally, back up. My original scenario was based on just like civil criminal activity. It's debatable that you could already attribute deaths to cyber warfare, which is a very different thing. But in your term, in answer to your question, yes, most of the major militaries already tightly integrate cyber warfare into what you would call physical warfare. And it's only going to get more intertwined as time goes on. It's just becoming integral in all the planning, everything you think about and everything you do. And it's also having closer and closer ties to kinetic effects as time goes on.
I think that will include things like propaganda.
I would say it already does.
Yeah.
Russia's activities in Eastern Europe involved coordinated cyber activity. And also you have to understand a lot of countries have a very fuzzy line between state-sponsored criminal activity, you might call them militia activity, all that kind of blurs. It's not as distinctive as it is, say, in the UK or the US.
Yeah. And also the insurgent activity is often based on the internet. I mean, I have a T-shirt that I bought in Egypt that says that it's about the revolution that overthrew Mubarak, and I can't wear it because it's too small for me. But it says on it says Facebook, because they were using Facebook to propagate messages about the revolution against Mubarak, and that these big Tahrir Square protests were all like, it was on Facebook, go to Tahrir Square now, and hundreds of thousands of people showed up. Some of them died because the Egyptian military shot at them, but you talk to the young people who were there, they said, we want our freedom. Now, they
won their freedom because the Egyptian military allowed them to win their freedom.
Well, they could have killed all of them, but
they could have, but they waited until Mubarak had been put out of power before they dispersed the protesters. And if you've ever seen the video of when they actually did come in and disperse the protesters at Tahrir Square, it's pretty obvious that they could have done the same thing weeks earlier if they had wanted to.
Yeah, but the world was watching. They knew that that with Mubarak, you know, and I drove by Mubarak. Well, I was driven by Mubarak's headquarters several times, burned. I mean, you could see the scorch marks all over the building. He
was a useful symbol to allow to fall, but the power still lies with the Egyptian military.
Oh yeah, I mean, yeah, I know what you're saying, but there was a feeling, there was a sense in the air that, you know, we showed up, we paid the price and we won, even though the victory is not clear cut. Anyway, I don't want to get too involved in that. Okay.
Yeah. And one last note, in a similar vein to what you're saying there, here in the U.S., we almost had a fake news cause deaths in the pizzeria incident.
Yeah, the Pizzagate episode.
Yeah, yes. That was near me. And I was very disturbing. Some, guy who kind of was mentally a little bit unstable showed up and started firing shots in this totally innocent pizza place because he had heard that they were doing child slavery there.
Yeah, it's a perfect example of how things can spin out of control when you get a lone wolf actor who's unstable and working off information that most people would be able to recognize as false, but if you're disabled, you can't recognize that.
Right, and it's kind of it had already been. I think it was a week before that, or maybe 2 weeks. It had already been all over the internet. This is false. The pizza child slavery thing is completely made up. But the guy had already made up his mind he was going to go there and use deadly force to try to free the children. I mean, his heart was in the right place, but his mind was way off in La La Land. And so anyway, he's now in custody. Nobody got killed, but it was pretty close. I think he could have easily killed someone. Chris.
So if you had a state-sponsored campaign of misinformation that could be escalated and draw people in and get them to act in concert, then you could have serious consequences.
Sure.
That's Donald Trump's election campaign, isn't it?
Well, it wasn't state-sponsored, but Donald Trump's election campaign was...
It may have been state-sponsored. We don't know the extent to which the Russians were involved in propaganda activities.
That's true. Nobody knows that in any depth. With regard to the WikiLeaks emails and so forth, and it may be years before we really understand what happened there. And I don't want to jump the gun. It may have been not much, or it may have been a lot.
Well, this sounds like the opportunity for a prediction. When will we know?
But that's not my prediction. Okay, Chris, are you with us? No. Okay. I guess
Only in spirit.
it's your turn, Nick.
Okay, my prediction is that since you specifically asked for a near-term time frame, 3 to 10 years, I will push that out to 10 years and say, with a 95% degree of confidence, there will be no unambiguous SETi detection of an alien signal within the next 10 years. And if you like, I push that out to 20 years and still maintain my 95% confidence
Okay,
rate.
what's your reasoning behind that?
I think that we are alone or nearly alone in the universe, and that if we're nearly alone, that means civilizations are rare. They probably appear at great distance from each other, and widely separated in time. So widely separated in time and space, even if there are multiple civilizations, creating the likelihood being very low. But I'd like to point out that even though I'm highly confident that there will be no unambiguous detection of a SETi signal, I'm also highly confident that this is a prediction that can be definitively proved false. So if a signal is detected, if it is determined to come from outside of our planetary system, and if the representation of that signal in information terms can be shown to have a 5 sigma deviation away from randomness, and it can also be shown as not from a natural source like a pulsar, clearly it's a prediction that can be proved wrong. I'm just saying it's not likely to be proved wrong.
Right. Okay. Adam, what do you think?
I think that Nick is mainly right. I would agree with him on most of what he said. I don't think we're alone in the universe. I think that there probably are other sentient beings. I do think that there is other life in the universe, but extraterrestrial intelligence, I tend to agree that it's thing is probably very large cosmological distances away, and there is absolutely no reason why the nearest other intelligent civilization should coexist with us at the same time in the same small patch of the universe. So within 10 years, a SETi signal, I would agree with Nick. I don't think it's completely out of the question that we will never ever receive a SETi signal, but likely because it would have to be aimed at us, which presupposes that they know we are here and able to receive signal. It presupposes that they would have to detect us first and want to communicate with us and be able to communicate with us. There are all sorts of different reasons. And then it also presupposes that we would recognize a SETi signal, which isn't given at all. What would a signal from an extraterrestrial civilization be? What would it look like? Sound like? We have absolutely no idea.
Well, excuse me for interrupting, but that's one of the reasons I framed my prediction in terms of a scientifically verifiable deviation from random noise, because we can, even if we can't interpret a message, we should be able to interpret whether the information encoded in a signal represents something that is on the one side not purely random, on the other side not purely predictable like a pulsar pulse.
Yeah. Again, I find it difficult to attach to it. Less than That's something like about 0.75.
Okay.
Favor of
0.75. Wait, just two significant digits?
yeah, just two this time.
Okay, Ken.
Okay. Well, reluctantly, I agree with Nick. I think the odds of a clear SETi signal are pretty remote for a very long stretch of time. For the reasons that are already given. If I could throw out perhaps a alternative silver lining, though, I think in that same time period, there's a very high chance that we'd see clear indications of another habitable planet. Our technology in that area is advancing fast. So I'm optimistic that we'll see something good in that range. But as far as a SETi signal, I agree. Very, very low probability.
And I agree with what Adams said, that life is probably common, and Ken just said that we'll probably find habitable planets. And I would say probably within 20 years, we'll have the technology to start finding definitive biosignatures from exoplanets and confirming life. And if we can send missions out to the moons of Jupiter and Saturn, we may get another sample of rudimentary life from even within our planetary system. All of these things which are entirely consistent with the fact that there not being another transmitting civilization that we can detect. Also, we can even predict the biospheres with complex sentient life that haven't, transmitted a signal we can detect in our direction. So those are all consistent with the no unambiguous SETi detection.
Okay, I'm afraid Chris Prophet is having a lot of difficulty getting back into the Hangout. He's tried many times. So I'm going to go ahead with my take on this. I'm going to be a bit of the contrarian compared to Nick. But I'm also going to express some epistemic humility. I don't really know. But in fact, I don't have any confidence in any prediction about the SETi, whatever. So the problem is there are two huge issues here, which we don't have any idea about. One is, how long do technologically advanced civilizations persist on average? That's the L in the Drake equation. And it could be, if it's just a few hundred years, forget it. We're never going to see them. It's like flashbulbs popping off in a stadium. What's the odds that two flashbulbs are going to pop off at exactly the same time? Pretty rare, right? So unless they're right near us, we never see them. The question is, and the other question is, how much do they want us to know that they're there? They may either not care, or they may be quite careful about letting anyone know that they exist. They may be happy where they are and not want any interference from anyone. So those two things together, again, we have no idea. My purely emotional sense of it is that, yes, they do that civilizations do get to a point where if they get through this bottleneck, they're essentially immortal. And two, by immortal, I mean they live for millions, even billions of years. And two, yes, they would want us to know that they're here. They don't know that we're here yet. But they might have a very good idea that this is a planet with life, because it's been a planet with oxygen for over 2.5 billion years, which means that everywhere in the galaxy, if you have a good enough telescope, you can see that this is a planet with life. Good enough telescope meaning a telescope way beyond our current technology, but still. So my sense of it is that 10 years, yeah, I would buy that, with 0.6, we're probably not going to get anything, because A, we don't have much resource to search for. SETi resources are not very good, and B, even the best telescopes we have, radio telescopes and optical telescopes we have, can only survey a very tiny amount of the sky at any given time. So we can easily miss a fantastic signal aimed right at us, easily. It might be aimed at us for days, and we wouldn't see it. For example, the fast radio bursts that are probably natural in origin, very probably natural. The current best estimates is 1,000 to 10,000 of those a day. We actually detect a few of them a year. Why is that? Because the big radio telescopes that are sensitive enough to detect them have extremely small beam width. They only look at a very tiny part of the sky. So they're popping off all over the place. We're not seeing them. And because we simply don't have the sensitivity to see them. So the SETi signals can become impinging on us all the time, and we're just not seeing them because we don't have the capability. We can only see an extremely tiny amount of the sky at any given time. So, yeah, I'll buy that Nick's notion that in 10 years we won't see anything. In 20 years, with the vastly improved radio telescopes, not only as the square kilometer array, but also the proposed improvements to the very large array in New Mexico, we might very well have the ability to see it. So I'm going to, at 10 years, I would say 0.6. At 20 years, I would say 0.4.
Do you think that there's any possibility that there will be any parasitic SETi searches using the James Webb Space Telescope when that starts operation?
Yes, I think that we have the really exciting thing that we've seen in the last 10 years, maybe 15 years, has been a shift from SETi is silly and ridiculous to SETi is worthwhile. Amongst
that has been the shift.
Amongst that very mainstream. The young astronomers, the young astrophysicists that are out there now, who are leading the way, have gone from this is a ridiculous waste of time to this is worthwhile if we find something that's got really good evidence. They're still very skeptical, but they're not willing to throw something out, not willing to throw the baby out with the bathwater.
And I think you can see how that plays pretty clearly in the public sphere. I was reading some scientists a few weeks ago talking about exoplanets and biosignatures, and they said, well, yeah, but when you talk to a crowd of people, what they really want to hear about is, have we found life and have we found intelligent life? So there's a lot of that. There's a real hunger for that in the public sphere. And hence, there are unscrupulous people who meet that need with less than stellar resources.
Well, there's a lot of media who
overplay it.
Are mysterious alien, whatever.
The M word.
We've been there before, right? Yeah, mysterious.
They use the M word.
Just say mysterious on anything, and you get clicks.
Mysterious images on Mars.
Yeah, or anything mysterious. Yeah, I agree. That's quite shameful and needs to stop. If you're listening out there, you're doing this shit. Stop it! All right. Are we done? Okay. Thank you, Nick. Chris, apparently, we've lost forever. So well, not forever, but for tonight.
Can you get him to make his prediction by text or email or tweet it in?
I'll see if I can get a hold of him. Talks amongst yourselves.
Well, I would, since you're inviting us to talk amongst ourselves, I'd like to mention the three of the things you mentioned about my prediction, which were the breadth of the survey, the sensitivity of the survey, us being a survey for SETi signal, and the funding that's available, all of which are, extremely marginal right now. I could respond to that by strengthening my prediction, and I can say, even if within the next 20 or 30 years we built a huge radio telescope in orbit or on the dark side of the moon, we still, with 95% confidence rating, are not going to detect an unambiguous SETi signal, though we'll be flooded with false positives, because the more sensitive array we build and the more sensitive radio telescopes we build, we're going to learn a lot about the universe. Even if in the unlikely event that a huge radio telescope were built for a SETi search and it were used for a SETi scope, it would discover a lot of things that weren't SETi signals. It would be very exciting, and we would learn a lot about the universe, even if we didn't learn anything about intelligent aliens.
Yeah, I agree. I agree completely with that, Nick. I've been quite pessimistic, and I am actually quite a fan of SETi. I do value SETi as an organization and as a means of exploring the universe. Yeah, there are problems. There are a number of problems with being able to receive. The biggest problem for me is always going to be, why would anyone send the species civilization send us a signal when we've not sent anything to them? And I don't think we will. I don't think that's a different kind of prediction. Do you think we'll ever start broadcasting to stars?
Well, we do broadcast the stars now. It's just these are small private projects that are not well funded and not very powerful. And of course, it's very controversial. There've been at least a couple METI debates where the people got and had their two tables on each side of the room, and they debated a proposition about whether people should engage in messaging or not. But I'd like to make one other suggestion in regard to Adam just said, why would anybody transmit at us? As Paul noted earlier, there's been oxygen on Earth for 2 billion years. There may have been biosignatures detectable in the terrestrial atmosphere for 3 billion years, maybe 3.5 billion years, depending. If you were an advanced alien civilization and you had that kind of telescopy technology that you could look at exoplanet atmospheres all throughout your galaxy and perhaps in other galaxies, you would have a wide database of alien biospheres. You would have all kinds of data on them. You wouldn't have necessarily the kind of data you'd have if you went there and you took soil samples, but you would know what the composition of the atmospheres is, and just as importantly, you would know on average how they evolved. And if you got clever enough at this, and I think scientists, a few hundred years from now could certainly get clever enough to start creating a taxonomy of biospheres and typical forms of biosphere evolution. If you did that, you could then focus on those biospheres that were most likely to produce complex advanced life, and then some small percentage of those that produce complex advanced life would create brains that were large enough to create intelligence. And you could narrow your search down to a few really good candidate worlds, and that would be a reason that they would focus on them.
I don't know if you could narrow that search down to just a few worlds, though. We don't yet know how similar or dissimilar the Earth's atmosphere is to millions of other planets strewn across the galaxy. So we don't know how prevalent life is, and we really don't know. Looking from 12,000 light years away at Earth, they're looking at the Earth as it was 12,000 years ago. They couldn't detect the industrial society we have now, detect our technology, unless they were very, very close, which is highly unlikely. I think we just further characterize the planet's solar neighborhood and in our galaxy before say that.
I agree. There'd be no technology that could be detectable 12,000 years ago. But what I'm suggesting is, if you have a large enough, say, 90% of planetary systems have a world with rudimentary life. So you'd have hundreds of millions within our galaxy alone. You'd have a very wide sample of data, and you could track that data, and you could see typical patterns of development. Some worlds would stay dead simple, microbial mats, and some would demonstrate evolution toward more complex forms, and you would want to focus on those worlds that only took the turn toward highly complex life. Now, obviously, I don't know how to do that now, but I don't think it's beyond the capacity of science, our own science, within 100 or 200 years to get to that point.
That would still only include life as we know it.
Yes, admittedly, or close enough to what we know it. Something, obviously from what we know about how plentiful carbon-based organic molecules are in the universe. That's what we're going to look for, because that's what's out there.
Yeah, I mean, all we can really look for is what we know, right? I mean, looking for something we have no idea what it's like is pretty hopeless, unless it comes knocking on our door.
Yeah, and is hungry.
Yeah, well, it comes to serve man. Okay, well, I guess it's time for my prediction. I'm afraid we've lost Chris for now. Seems to be technical difficulties. My prediction is closer to home, much closer. And it has to do with climate change. As you're probably aware, I've been pretty involved lately with reading David Grinswood's book and getting ready to interview him. And as I did a couple weeks ago, and this had to do with the fate of the earth and the turn away from fossil fuels, which appears by all indications to be causing a heating in our planet. Now, I'm not going to go deeply into what David was talking about in his book. There's a lot there. Please visit wowsignalpodcast.com to learn more about that. But I went and looked at a couple of things. First of all, not all the carbon we're putting in the atmosphere is due to electrical power generation, but a significant chunk of it is. And a significant chunk of that is coal. Not in every country. Now, in Europe, they don't burn that much coal. In China, they burn a lot of coal. Here in the U.S., we burn a lot of coal. So I focused on the U.S. here, and I said, well, how much coal do we produce? And I looked it up, and according to the U.S. government, we've recently peaked our coal production at about a bit over 1 billion short tons. A short ton is it's whatever you think a ton is, right? It's 2,000 pounds. 1 billion short tons of coal were produced in 2015. And my prediction is that by 2017, the U.S. production of coal will be 400,000 tons, about a 60% reduction from current production. And this is because coal is uneconomic. It's not the cheapest way to produce electricity in nearly all of the United States. It's in fact, a large part of the land area of the United States, the recent studies show that the cheapest way to produce electricity is wind. We have these big prairies, these big Great Plains, and wind is the cheapest way to produce it. Nuclear in some areas, natural gas in other areas, and solar.
When you say cheapest, do you mean most efficient?
No, I mean the lowest cost per kilowatt hour, taking into account the environmental cost. So now, how you take into account the environmental cost is something reasonable persons could disagree about, but they did their best to try to account for that. That is, coal has a couple of costs. One of them is it puts a lot of CO2 in the atmosphere. So does natural gas, but not as much. And second, coal puts a lot of pollutants in the atmosphere, and that can cause health problems as well as other environmental costs. So they looked at coal. They looked at a couple of different natural gas alternatives. They looked at nuclear, they looked at wind, they looked at photovoltaic. There are some parts of the country where, particularly in the Southwest, where photovoltaic is the cheapest way to produce energy, both residential photovoltaic and industrial photovoltaic, that is big solar arrays versus putting one on the roof of your house. Certainly in places like Arizona, where the sun shines nearly all the time, and you're at a relatively low latitude, it makes a lot of sense to have a photovoltaic. In places like Nebraska, it makes a lot more sense to have wind turbines, because even though a wind turbine is pretty expensive to put up, it produces a lot of energy for the cost. So if coal is going to become economic, now there are political forces, including the recent president-elect's pre-elections, that would be pro-coal. But still, I think coal is on its way out. Fossil fuels are in general on their way out, although natural gas will take a little bit longer to get rid of. And we even in this country burn a little bit of fuel oil to produce electricity. That's clearly on its way out. But nuclear has been suppressed for many years since 3 Mile Island, even though no one was hurt in 3 Mile Island. It created enough fear to keep us from building more nuclear plants. We have only a few nuclear plants in that are actually working right now in the U.S. And Chernobyl, again, reinforced that fear and resulted in, basically slow or no growth in nuclear power in the U.S. In Europe, there's a lot of nuclear power. There's also solar and wind, and we've all seen the movies about how those poor coal miners are being pushed out of their jobs, but the reality is that we have to get rid of coal. And so that's my prediction. By 2027, 400 million short tons of coal.
What is it now, Paul?
In U.S. What?
What's the production now?
A little bit over 1 billion. China is higher. China has vast coal reserves, but China, we know from the horror that is their air pollution now in China, that they are working hard to get that down.
I believe China now has more solar voltaic installed in the U.S., don't they?
I believe they do, but still, you see the pictures from Beijing.
Oh, yeah, we all know that the air pollution is absolutely horrible there. And if you read about the coal industry, and it's really dirty kind of coal they have available there, too, it's a disaster. And we also know that as soon as a society starts to become wealthy, people care a lot about the cleanliness of the air, the water, and the land.
Oh, because you can, right?
Because you have that luxury.
Yeah, but interestingly enough, in the lesser developed countries, there is a real push towards renewable energy. They understand because not because they do care, but not just because they care, but because it's getting cheaper.
Well, and they have the opportunity to leapfrog it, which the industrialized countries never did. Just like the countries that never put in, a really good functioning landline phone system, and they could go directly to cell phone towers without ever having to build the landline telephone system. If you can leapfrog, or never building a big mainframe computer, just giving people laptops because it's easy to ship laptops into a country rather than bring in a IBM to build a room-sized computer with distributed terminals.
And the common element of that is it's decentralized and distributed, like you said. So it's a bottom-up process instead of a top-down of large plants. Okay, well, let's start. Let's go through this. Adam, what do you think of my prediction?
I'll begin with a question.
Sure.
People in your neighborhood have solar panels on their roofs?
Yeah, some do. Although it's getting more common than it used to be.
I ask everyone question. How common is it in your neighborhood for people to use solar energy? And
It's probably just a few percent. On the other hand, on the industrial scale, Texas is the biggest wind energy producer in the U.S.
you'd say the same.
Well, I live in Oregon, which it's very cloudy and it rains most of the time. So there are a few places with solar panels, and people pride themselves on their progressiveness here. So their solar panels are visible in Portland on the roofs of buildings, but there's still probably, like Ken said, just a few percent. There are some places where it's windy and there are wind turbines maintained. So once again, like Ken said, there's some industrial scale production of wind power. So there's a mixture of renewables, and it's not supplying the grid on a main scale yet. But of course, also in the Pacific Northwest, we get a huge amount of our energy from hydropower because of the dams on the Columbia, and then there's some big dams up in BC and other places in Canada. So most of the grid is actually supplied by hydropower rather than fossil fuels in the Pacific Northwest.
I have a difficulty in trying to gauge enthusiasm for renewable energy in the United States. I'm not there.
Well, I think I have to tell you, I think it's gone from 0 to something very quickly.
Yeah.
I believe that a lot of this, I cannot go out and drive to work without seeing a Solar City truck on its way to a job every day in the Washington D.C. area. Now we're about 39 degrees north latitude. Where you are, I believe you're quite a bit further north than that. It's going to be a little more difficult to make solar power work. But and my friends who live in Arizona or California have for them it's almost a no-brainer.
Yeah.
It makes economic sense. It makes sense to them in terms of their electric bills to invest in a solar roof.
And the price per installed kilowatt hour is plummeted by about an order of magnitude in the last 15 or
Oh yeah, it was down
years.
30% just last year.
Do you not think that the Republican administration that's going to take over next year will want to boost coal production in the United States?
Yeah, I think they will, and that's very worrying. But anyway, what's your assessment of my prediction? Going from 1 billion tons to 400 million tons in 10 years.
I think you're being overly optimistic. I have no idea about the coal reserves in the United States.
Oh, we have lots of it. Let's assume it's infinite.
Well, given what I know about your president-elect and his administration, which isn't a great deal, to be honest, I don't think there will be a big push towards renewable energy in the United States. From the top up, it's more likely to be a bottom, not top down, bottom up. It's more likely that individuals will take it upon themselves to install solar panels. I can't see a big drive towards wind energy, solar energy. Within the next 4 years, no, I can't see it. Maybe within the next 20 years.
How about 10 years?
10 years, yeah. If you said 10 years, then that's more realistic, yeah.
Okay.
More just overly optimistic, Paul, I'm afraid.
Okay, Chris, can you hear me?
Yeah, can you hear me okay?
Yes, fine.
All right, sorry about that, just dropped out. I had a cold reboot and I'm back. I didn't hear all your prediction, but I mean, basically that's the way it's gone in the UK. The coal production has just gone to really low levels because, I mean, it's just untenable. You can't burn the stuff where you live. It's no good. So I do have to agree, though, about the point that with the new administration, everything's up in the air. Really, Republicans are well known for being conservative about energy and what have you. I know some guys are attacking Elon at the moment, some big energy concerns, because they're rather worried that he might be undermining, the existing status quo as regards energy. So, yeah, one to watch.
What about you, Ken? Your mic is muted, Ken. Unmute.
It takes me a minute to get it unmuted. I don't think it'll fall quite that fast. There's also a negative feedback mechanism in any kind of energy sector where if use decreases, the price falls, and that triggers a use increase. If you couple that with the potential of cleaning up to some extent power production from coal, I think I would stretch that level of fall out to 10 to 20 years before you could expect to see that. And similar to what Adam and Chris have said, I think you'll see despite what may be the top-down direction, you'll see the bottom-up organic drive as a bigger factor in the long run.
Okay. What about you, Nick?
I largely agree with Ken, although I'd give 65% confidence in your prediction of that much of a fall, and the farther you push it out in terms of a timeline, the more likely we're going to be. I do agree with you completely that coal is on its way out. Fossil fuels on their way out. Chris Profit mentioned that the coal production really fell in the UK. Part of that reason is it's expensive to extract coal with miners. When the big coal strike happened, I can't remember if that was 81, 82, or 83 under Thatcher, it would have been cheaper for the British government to take all the miners off of work and just give them the money directly, because they were subsidizing the coal industry so heavily, than to have them continue to mine coal. But these were symbolic jobs, just like all the carrier air conditioning jobs. When the television cameras show up at a factory and they say, "Oh, these people are going to be put out of work. This is terrible," then they become symbolic jobs. But you're not looking at the whole of the economy and what's happening and the inefficiencies of supporting old paradigm power like coal. So yeah, coal is on its way out. The exact flux of how it's going to bottom out eventually, it's difficult to predict, as Ken pointed out. If it gets cheap, people might find a use for it, but it's on its way out. And I would, like I said, I'd give about maybe 65 to 75% confidence in what you're suggesting.
Okay. Chris, you get to go last with your prediction.
All right, great. Well, it's not very cheery, unfortunately. As far as I can see, that there is no limit on satellites in orbit at the moment. There's some big constellations coming down the pipe. 4,425 satellites for SpaceX. I think Boeing are looking at a 2,000 satellite constellation. We've also got OneWeb. They're looking at 667, something like that. And these are just the big constellations. Of course, there's going to be an awful lot of other satellite launches for all around the world. For everybody's going to be putting satellites up there. So we've got in continual increase in numbers, and unless they're very low orbit, they don't decrease in number. So I think we're going to see a sort of a limited effect Kessler in the Kessler syndrome, whereby, satellites collide or they get impacted by space debris and they cause more debris. And we're just going to see more satellites go out of service. At the moment, it's very much similar to the asteroid threat. We sort of know there's a threat, but we sort of ignore it because we can't say, oh, well, this is the threat or that is the threat. At the moment, we know that we're just increasingly putting more and more stuff into space, and it's going to happen sooner or later. I predict that within 10 years, we're going to have sort of NASA and maybe a few other space agencies seriously looking at mitigating space debris. I do actually have a rationale how that can be brought about, but I'm not sure you're going to like it, Paul, because it involves EM drive.
Well, I don't like that, but I tell you what, I can't talk out of school, so I'm involved with this sort of thing myself. So I'm going to let the four of you give your assessment of this. Okay, Adam, what do you think?
Quite catch all of what Chris said, but you're talking about the Kessler syndrome, problems in low Earth orbit, yeah?
Well, I mean, no, all orbits. I mean, low Earth orbit, medium Earth orbit, geostationary orbit. I mean, you only need to have like an asteroid go into some of those geo satellites, and that could be a real mess up there on that very tight ring of satellites up there.
Satellites are getting much cheaper to launch and replace every day.
Yeah.
So I don't think, and there's also a tendency now to launch large constellations of satellites so that one gets knocked out, there's a backup. That it works two ways, because I take your point that space is getting a lot more crowded. The L2 Lagrange point being very crowded, and so there is like an accident waiting to happen, and eventually something is going to collide with something else. People have been talking about this happening ever since the International Space Station first began. There's been a film about it, Gravity, about thing disastrously crashing into the International Space Station. The Space Command that are in charge in America of plotting the course and trajectory of all the objects in orbit, I think that they do a very good job of it. And I'm quite torn between whether to agree with you or not, because I tend to see it as accidents as being completely random events that we can't predict or find they're very unpredictable. We're talking about predicting something which is inherently unpredictable, because what you're describing is an unpredictable event. So I find it very difficult to attach a predictability to something that's so unpredictable.
Well, that's part of the exercise, Adam. You have to still. Are you going to hit the crossbar, or are you going to go into the back of the net?
I'm going to go for a near miss off the crossbar, I'm afraid. I don't think eventually in future history it is a given that eventually there will be some sort of accident in space. It's going to happen eventually, or it's going to happen in the next 5 years, 10 years, probably not. So I'll give I'm going to say about 0.35.
Okay. The actual answer is 0.36, but okay, Ken.
Okay, well, if I understood correct, the prediction was that we'll start trying to clean up space. Was that correct? Clean up the orbit?
That's it.
Okay.
I mean, it's undeniable, as I see, that there's going to be more collisions because we've already had them, and there's plenty satellites going out of service all the time, and they say, oh, well, that's just a natural thing. But I think it's going to happen with increasing frequency, and we're going to have some way of addressing that problem. Yeah.
Yes.
Spot on.
I agree with you. I think that it'll either become either a national or an international project and funding to start actively cleaning up the debris in space. And in fact, I think that's a commercial opportunity for somebody. So yes, I think within 10 years, I agree with you. They will start some initiative to clean it up. Could even be out of military necessity. That's where you tend to have more readily available funds to do something like that on a direct basis. But no, I agree, and I hope they do start cleaning up, because there's just a mess up there.
What's your assessment? What's your assessment of the likelihood of Chris' prediction?
Within 10 years, starting a project like that, I'd say 60%.
Okay. Nick?
In terms of a major enterprise to mitigate space debris, I would put within 10 years, I would put the probability even higher. I would give it 75 to 85%. I would not put an actual Kessler syndrome event. I wouldn't put that very high, maybe 10 to 20%. But certainly the danger is there, and the danger increases with the number of satellites that are launched. The cheaper they get, the more that'll go up there. The more they're up there, the more likelihood there is of a Kessler event. So it certainly could happen, and it might eventually happen. But clearly there is an awareness of the danger. The awareness of the danger will prompt efforts, and so I see an effort to mitigate space debris within the period of time.
Okay, well, sorry, somebody want to talk?
Right, I disagree. I think my experience tells me that we won't start cleaning up until it becomes a major problem. The way human nature works, more likely to see an accident, failure of critical satellites before anything is done about the problem. It's an unfortunate way that humans operate.
Okay, well, like I said, I'm not going to render an opinion on this, but I will give you a few facts. There are a lot of policies in place now about orbital debris, and they are largely followed, even in the international community. For example, many of the larger satellites are designed to be controlled reentry. Pretty much everything below 500 kilometers cleans itself up because the atmosphere will drag it down. That's the space station and the shuttle altitudes, and a lot of other satellites are in those altitudes. They will come down within a few years. Above 500 kilometers, which should include the proposed SpaceX constellation, which I think is 1,100 kilometers. Correct me on that if I'm wrong. It come down very slowly, if at all. In fact, really above 1,000 kilometers, they basically don't come down. So, but there are debris mitigation policies in place. The higher you go, the less of an issue it is. In GEO, there is a largely followed policy. I can't say everybody follows it, but nearly everybody does. That when you retire a satellite in GEO, you raise its orbit before you retire it. And that, I think nearly everyone does that, including Adam's dog. What's your dog's name, Adam?
Blue.
Hello, Blue. I think Blues are terribly interested in our podcast, but anyway, so those are some facts. NASA very rigorously follows orbital debris policies and is quite serious about it. I can say that. And also, there are extremely few events to which we can attribute damage to orbital debris at this time. It doesn't mean there won't be more in the future. It just means that right now, not many. NASA has a lot of satellites flying on the few hundred kilometer altitude regime and sees basically no damage due to orbital debris. So, and at that point, I probably said enough. Okay. At this point, we go around, everybody gets to make a recommendation, and I did. I don't know if you guys got the memo, but if you have a charity to recommend, because it's the holiday season, recommend that. Otherwise, just make a recommendation. And we'll start with Adam Smith.
Gosh, well, I completely forgot to give a recommendation, and I can't charity recommendation off the top of my head. So I am just going to recommend music, songs of someone someone that I've been a very big fan of since I was about 13 years old. That is Britain's finest singer-songwriter, Mr. Paul Weller. I will supply some links to YouTube videos. Never heard of Paul Weller? Look into it because you're missing something.
Okay. Paul Weller. I should look into that because I don't know much about it. Paul Weller.
Shame on you.
Yeah, well, I mean, now, I would point out that this week we lost Mr. Greg Lake. I don't know if I call him Britain's finest singer-songwriter, but I miss him. Okay, how about you, Chris?
Oh, I say there's so many charities and we're so many different areas. I can only recommend we find a local children's charity. Like Ormond Street or something like that helps children in your area. Because it's Christmas, they do a great job. As regards another recommendation, I really recommend National Geographic's new series called Mars. It's spot on a lot of stuff, and yes, the first episode's an infomercial for SpaceX, but besides that, they've got some very good talking heads on it, and who seem to know what they're on about. So I definitely recommend.
Yeah, I like it. A little bit too much Robert Zubrin for me, but still, it's pretty good.
Well, they edited him down. He was very calm. I don't know. It was a lot of jumps.
Yeah.
From one.
Okay. Ken.
Yep. Sorry, it just takes a while for my mute to go off.
Oh.
I got two things, one book, one charity related to our topics tonight. On a book topic, I'll recommend Thinking Fast and Slow by Daniel Kahneman. It's really related to what we're doing tonight because it goes into a lot of detail about how your brain serves information up to you and some of the tricks it'll play on you. And that ties into the fact that we think of the future in linear terms. And so it's a dauntingly thick book, but not a hard read. Daniel Kahneman was a psychologist who won Nobel Prize in economics, talking about the irrational actor in markets. On a charity side, something to think about is SETi at home, where you can, one, either give money or allow your computers to be used in their unoccupied time to contribute to SETi signal analysis. So you can be a small part of that very big project.
Okay. How about you, Nick?
I'd like to affirm what Ken said about Thinking Fast and Slow by Daniel Kahneman. It's a really wonderful book. It is a book that really brought cognitive bias to my attention in a serious way, and it literally changed the way I think about things. And it's quite comprehensive, so it covers a lot of different cognitive biases. But it's also very detailed in its treatment of a few of them. So I can concur on that recommendation. And I'm not sure exactly what qualifies as a charity, but I'd like to recommend Icarus Interstellar, with which I am affiliated in a small way. So give till it hurts to help make interstellar travel a possibility or a reality sometime in the coming century.
Okay, thanks, Nick. By the way, I've dug a few chapters of Thinking Fast and Slow, and I concur that it's quite a good book. But it's in my stack of books that get multitasked in and out. My personal recommendation is Doctors Without Frontiers. They do really critical, really important work in very dangerous places. They sometimes get killed for it. It's very expensive work. So it's not that the doctors themselves are asking for fees. It's that you have to get a lot of equipment and a lot of stuff to these dangerous areas like Haiti or Syria or Afghanistan. So Doctors Without Frontiers could use your help. Send them a few bucks this Christmas season, keeping in mind there are people out there who are dealing with extreme danger and extreme stress, even as we are partying and having a good time. So that's it for this episode 64 of the Unseen Podcast. We'd love to hear some feedback from you. If you have any questions or comments, I didn't see anything on Twitter tonight, but if you have anything you'd like to say offline, you can go to our blog at unseenpodcast.com. You can go to our community on G+ or our subreddit on Reddit, and all those posts will be read and taken into consideration. You can also email us at unseenpodcast@gmail.com. Our Twitter is @podcastunseen at Twitter. So there's lots of ways to get in touch with us. If you have an opinion, a comment, a question, whatever, a forecast, a prediction, we'd like to hear from you. If you'd like to be on the panel for a future Unseen podcast, why not? Why shouldn't you be? You can email me at unseenpodcast@gmail.com and I'll let you know how you can get on. Or just go to our website, unseenpodcast.com, and you'll learn all kinds of things about how you can get on, what's expected of a panelist, how you become a panelist. And so I'd like to thank my current panel tonight, Adam, Chris, Ken, who's on for the first time, and Nick. And we will see you again in January. This is the last, as I mentioned, the last episode for 2016. We'll do the Unseen Pub, which is our video series, which is completely unstructured. And yes, you can join in on that too. We will actually post the link to the Unseen Pub after everybody else has had a chance and you can come in there and talk. And we just chit-chat for about an hour. That'll be on January 6th. January 13th, we'll be back for episode 65. The topic is yet undetermined, and we'll just keep going on. I'm hoping to get David Grinspoon on at some point in January, February to talk about his book, Earth in Human Hands, if there's enough questions. If you have questions or interesting things to say to David Grinspoon about Earth in Human Hands, by all means, contact us and we'll get you on the podcast and you can talk to David directly. And he's written what I think is an important book that covers not only, it's not an environmentalist screed, although, well, could be. It is a book that covers Earth as a planet, Earth as a particular case of a planet, and could there be other planets like Earth, and could they have solved the same problems that we have in front of us now. So anyway, good night, everybody. This has been episode 64 of the Unseen Podcast, and we will see you in January. Good night.
Night.
All right.
Good night.